Hi guys, welcome back. So we are still working on questions that are still based on probability, particularly the tree diagram. So we have 8.1 here. It reads as follows. It says a bag contains 3 red and 5 yellow tennis balls. Player picks a ball at random, observes the color and does not replace it. She then picks a second ball. Right, so we now know that this is a case of without replacement. Right, so we know that we have a case of without replacement, meaning that after the player has picked out the ball, she only observes the color and then put it aside. She no longer replaces the ball inside the bag. So now we have 8.1.1. It says that, and then another thing that we have to look at here is that this is going to happen twice because she is going to pick a ball second for the second time as well. So we have 8.1.1. It says that draw a tree diagram to represent the above information, showing all possible outcomes. So now what do we have? We know that this is going to happen twice. And then what do we have at first? We have 3 red balls, and then we also have 5 yellow tennis balls. So now what can we do now? It is that we can just draw our tree diagram, noting that there is a case of not replacing the ball again, and then this is going to happen twice. So what are we going to have here? We are going to have this first. It's either a person, when he or she picks up the ball, she's going to get what? It's either a red ball or a yellow ball. So this is according to what we have here. So now, what is the probability of first selecting a red ball? This is 3/8. Right? Why 8? Remember that the total number of balls are going to be 8, since 3 plus 5 is going to be equals to 8. Right, so now what do we have here? We also have that the probability of first selecting a yellow ball. The probability of first selecting a yellow ball is 5/8 because we have 5 yellow balls out of 8 total balls. So now what do we do now? This is for the first try, or for the first pick. Then now let's go on to our second try. So remember that if a person picked a red ball, still stands a possibility to select what? To select another red ball, and also to select another yellow ball as well. But then remember here, there's a case of not replacing the ball back inside the bag. So now what do we have here? We have the red ball here, which is, now we took one red ball. We took one red ball and then we never replaced the ball inside the bag again. So how many red balls are we now left with? We are only left with 2 red balls out of how many balls in total? Remember, we have taken out one ball and then we never replaced it inside the bag again. So it means that we are now left with a total of 7 balls. So now we have this here. So since we have taken out the red ball, now what is the probability of now selecting a yellow ball as the second ball? So remember what happened here. We only took out a red ball, but then we never took out any yellow ball. So it means that we still have 5 yellow balls over how many balls in total? 7 balls in total. So this is what we have for the first case, whereby let's take the first ball was red. Now let's analyze the second situation that can also happen when the first ball that we can have here is yellow. So we know that the probability of first selecting yellow ball is 5/8. Then the probability of now selecting a red ball. What is the probability of now selecting a red ball? So let's have a look at it. Remember, we only took one yellow ball out of the bag and then we never replaced it. So it means we are still left with 3 red balls out of how many balls now? Out of 7 balls. So this makes that the probability of now selecting the red ball at second is 3/7. So now let's have a look at our second case here. We have y here, which represent the yellow. Now remember, we took out a yellow ball at first. Then now, what would be the probability of now taking a yellow ball second? If the first ball was yellow, then this was going to give us 4/7. Remember, why 4/7? Because the first ball that we have taken out was yellow, and then we never replaced the ball back inside the bag. So it means that we are now left with 4 yellow balls out of 7 balls in total. So now let's now write our outcome. So how do we actually represent our outcomes? So which is this part here. We are going to say it's either our first outcome that we can have, it's either we can have a red ball first and then a red ball after, or it's either we can have a red ball then a yellow ball. Then another outcome that is possible, it is that we can have a yellow ball and then a red ball. Another outcome that we have here, it is that we can have a yellow ball then a yellow ball again. So this is what we have here for our outcomes. So now let's now look at 8.1.2. So 8.1.2, it says that we should determine the probability that the player picks the balls of different colors. So now let's look at what would be. We know that this should happen twice, right? It should happen twice in a way that a player picks a ball first and then picks a ball for the second time. So now it means that it's either he or she can pick 2 balls of different colors. And then how is that going to happen? It's either a red ball is going to come first, then a yellow ball. And then another scenario that you can also have, it is that she can pick that a yellow ball first and then a red ball as the second ball. So how would we actually try to answer this question? So we have 8.1.2. So remember, it's either we can have a red ball and a yellow ball after, or we can have a yellow ball then a red ball after. So these are the situations that we have. So this is the probability of picking what? A different ball. So 2 balls of a different color. So now how are we going to answer this? Remember, if we are looking for the probability and we are moving across, remember we are looking for this probability here. Then how are we going to look for that? We know that we have to move across. We are moving across from red then yellow. So this will be this probability, which is red then yellow. So red then yellow. How do we get this probability? So this is going to be 3/8 multiplied. So this is 3/8 multiplied by 5/7. So if you are moving across, remember, if you are moving across to get this outcome here, we are going to multiply the 2 probabilities of the branches. So now let's move on to the next scenario that we have. Remember, we can have a yellow, then a red ball. A yellow ball, then a red ball. So how can we look at that? So now let's look at this in this way. We can first have a yellow ball, and then after having a yellow ball, we can have what? We can have a red ball. Then what do? We know that we have to add the 2 probabilities. But then now, what are we looking for here? You are going to say here, we have what? We have 5/8, which is the probability of first selecting yellow ball, then a red ball, which is what? Which is 3/8. 7. So this is the probability of this outcome, while this is the probability of this outcome here. So now when we put this inside our calculator, so when we punch it in, we are going to get that this is 15. Remember, this is 15. This is 15 over 56. And then while we put this, we still get 15 over 56, right? Because this is 5 times 3, and then still have 3 times 5 again. So now what do we do with this? We are now going to add the two probabilities so that we are going to get here 15 over 28, right? So this is how you actually solve this particular question here. So I hope you guys are going to now understand. So when we are looking for the probabilities across, when we are moving across from left to right to find the probability of a certain outcome, then we are going to do what? We are going to multiply. But then when we go down, or when we move vertically up or down, we are going to do what? We are going to add. So these are the two things that we should take note. And then this is the reason why we added here. We say that we are going to add here. It was because we are now interested on this part here. This part here and this part here. So we have moved up to down. So up, down, we add, and then across we multiply. So this is how we work with tree diagrams.